Okay, we are going to look at just a lot of extra linear stuff that really didn't fit into any particular lesson. So this is just going to be a whole mashup of stuff that's left over. So let's recall slope-intercept form first. We have y equals mx plus b. M is our slope, and b is our y-intercept. So if we want to write the equation of the line with the slope and a point, all we have to do is plug into that equation. So my slope is m, my points are always an x, y point. So I plug those into x and y. And we want to solve for the y-intercept because we don't have it yet. So y is negative 50 equals m is negative 3, x is 15, and we're going to solve for b. So remember, we have two steps to this. We're going to multiply negative 3 times 15, that is negative 45, and then we're either going to add or subtract. So this is a negative 45, so we're going to add that. And negative 50 plus 45, that is negative 5. So that's my b. My m was negative 3, so my equation is negative 3x minus 5. So y equals negative 3x minus 5. Okay, what if we're not given the slope? To find the slope, we use our slope formula. So our y2 minus y1 over x2 minus x1. So we have x and y of our first point, x and y of our second point, and we just plug those in. 5 minus 3, 3 minus negative 2. And when we plug that into the calculator, we're going to get 2 over 5. So that's my slope. To get my y-intercept, I'm going to do exactly what I did over here. So I'm going to pick a point. I'm going to go with this one. So y equals mx plus b. Y is 5. M we just found was 2 over 5. X from my point is 3. And we're going to solve for b. So again, two steps. Multiply 2 over 5 times 3. That is 6 over 5. And then I'm either going to add or subtract. This one's positive, so I'm going to subtract it out. And then 5 minus 6 over 5 is 19 over 5. So that's my b. So I've got m and b now. So my equation is y equals 2 over 5 for m, x, plus 19 over 5 for b. Okay, so we know how to do slope-intercept form now, which is y equals mx plus b. And we know standard form from the last lesson, which is ax plus by equals c. So we can convert between these two. So we can take this y equals mx plus b and go back to ax plus by equals c. Just remember when we're doing this, we have two little notes. X can be any integer which is greater than or equal to 1. An integer means, A. An integer means A cannot be a fraction and it cannot be negative. It has to be an integer that is greater or equal to 1. So no fractions, no negatives. So if I want this all ax plus by to be all on the same side, I need to get this 3x over there. To do that, because it's positive, because it's being added to 11, I'm going to do the opposite of that. Just like SAD Meg, I'm going to subtract 3x over. So I've got my negative 3x plus y equals 11. But remember, a has to be any integer greater or equal to 1. So it can't be a fraction. Well, I don't have a fraction here. But it also can't be a negative, and I do have a negative here. So to get rid of that negative, I can just multiply out another negative, or in this case, a negative 1. Because a negative times a negative, that'll give me a positive 3. But we have to carry that to everything. You can't just multiply it by one thing. It goes to literally everything. So negative times negative 3x is positive 3x. Negative times y is a negative y. And negative times 11 is negative 11. So all you're going to do here, you have two steps. You're just going to add or subtract that x over, depending on what it is, and then you can multiply. You may have to multiply a negative, you may have to multiply an actual number, but you're always going to multiply something out. So let's try it with this one. I'm either going to add or subtract my x. This one's negative, so I'm going to add it over. So I've got 1/3 x plus y equals 5. And remember, my a, what's with my x, cannot be a fraction, and it can't be negative. Well, this one's positive, so we don't have to worry about negative, but it is a fraction. To get rid of fractions, we just multiply by the denominator, by the bottom. And we still have to multiply it out to everything. So 3 times 1/3, that is just 1, so we can just put x. 3 times y is 3y, and 3 times 5 is 15. Now I've got ax plus by equals c. So you always just add or subtract x, and then you multiply. You may have to multiply a negative. You may have to multiply the denominator. You may have to multiply both. And you can do two things at once. You can multiply a negative and a 3. Or you can do them separately. That is totally up to you. Okay, next section, we're going to look at more transformations on these equations. So remember, changing b, changing your y-intercept, that's going to be a vertical shift up or down. If it's positive, it's going up. If it's negative, it's going down. Changing the m, which is your slope, that makes the graph steeper if it's greater than 1, or flatter if it's between 0 and 1. When that m is negative, that's going to cause your graph to flip, which is a vertical reflection. So instead of going up, it's going to go down. So let's look at these. This time we're giving you the graph instead of the equation. So the graph of g of x is here. So we need the equation for that. So we can start with our y-intercept. And then I'm going to pick another point. So this one's pretty good. And we do our rise over run. So I'm rising 2. I'm running 1. 2 over 1, that is 2. So that's my slope. And I got x plus my y-intercept, which is 3. So 2x plus 3. Now for h of x, it says h of x is just the same graph, but it's vertically shifted down 7. Vertical shift, that is your y-intercept. So I'm going to take that y-intercept and I'm going to move it down 7. So I'm going to go 1, 2, 3, 4, 5, 6, 7. And that's going to be my new y-intercept. I'm not changing anything else about this graph. I'm just moving it down 7. So my slope, that was up 2 over 1, it's still going to be up 2 over 1. Erase this little line. So that's still going to be my slope. And I can draw a line through that up 2 over 1. With my arrows, of course. So that is h of x. All you're doing is moving your y-intercept down 7 spots. So my slope didn't change. It's still 2x. But my new y-intercept, it subtracted 7 because it went down 7. So 3 minus 7 should be negative 4. And that is exactly what we graphed here. Okay, let's try this one. So the graph of g of x is shown below. So this is my g of x. So let's get that equation. So I'm going to start at my y-intercept, and one more point would be right here. So I'm rising 1, 2, 3, 4, 5, 6, and I'm running 1. 6 over 1 is 6. So that's my slope. And then my y-intercept is negative 2. So I'm going to put x minus 2. Okay, my new thing for h of x, my new directions, says it's going to be half as steep. Steep and flat, that's my slope. So if I'm half as steep, I'm going to take half of that 6. So 6 times 1/2, that means my slope is going to be 3. But it also says it's reflected vertically. So that vertical reflection, that means my graph is going to flip. So my slope is going to be negative. So instead of it being 3, it's going to be a negative 3. And it didn't say anything about shifting it up or down. So my y-intercept is not changing. So I took half of 6 to make it half as steep. And it said it reflected, so I made it negative. My y-intercept, that did not change. So that stays negative 2. So if I graph it, I'm going to start at the same spot, that negative 2. I'm going to go down because it's reflected, and I'm going to go down half as much. So before I went up 6, now I'm going to go down 3, half as much, still over 1. Just like my equation says. Erase all this extra. So I went down 3 over 1. So that is the line I'm going to graph. Okay. Next little section is parallel lines. Parallel lines means they're going to have the same slope, so the same m value, but different y-intercepts. So their b is going to be different. So these two lines right here are parallel. That means they're never ever going to cross each other. We can prove that by finding their slope and their y-intercept. So for A, my y-intercept starts at 4. I'm going to pick another point. I'm going to go here. So I'm going to rise 3 and run 1. And 3 over 1 is 3. So my slope is 3. My y-intercept is 4. So my equation is y equals 3x plus 4. For B, this one starts at negative 6. And for another point, it's going to go up 3 over 1. And 3 over 1 is just 3. So that's my slope. My y-intercept was negative 6. So this is y equals 3x minus 6. So these are parallel lines because they're never ever going to cross each other. And we prove that because their slopes are exactly the same. Their y-intercepts are different, but their slopes are the same. Think of it like a car. If I'm driving down the street, and my car's right here, I'm not going to draw a very pretty car, but that's a car. And this person's in the next lane. So we're in 2 different lanes, 2 different starting values, but we're both going 3 miles an hour. Are we ever going to be able to cross each other? Can I ever pull up and come in front of them if I stay the same speed? No, because we're going the exact same speed. So that's why these are never going to cross. They're going the exact same speed. They're both going up and up 3 over 1. So they're never going to come over towards each other. That's all your slope is. It's the speed of those lines. So if I don't have a graph and I want to find the equation that's parallel to this, but goes through a very specific point, I can use the same technique we used earlier to find an equation, just plugging it into y equals mx plus b. Because it's parallel means they're going to have the same slope. So this slope of 4, that's going to be the same slope of my new line. But they're going to have different y-intercepts. So this 5, that's not going to be my y-intercept. So I don't need that. I need the new point, the x and y here, and I'm going to find the new y-intercept. So I can plug in here. I got y, that's negative 28, equals m is 4, x is negative 6, plus b. And same 2 steps. I'm going to multiply, and then I'm going to add or subtract. So 4 times negative 6, that is negative 24. And then because that's negative 24, I'm going to add it. So b equals negative 28 plus 24 is negative 4. So my whole equation for my parallel line, remember it has the same slope, so it's still going to have a 4 slope. So it's the same speed, but it's in a different lane. So instead of it being in the 5 lane, it's going to be in negative 4. Okay, let's look at B. Remember, it's going to have the same speed, but it's going to be in a different lane. So it's still the same slope, but we're going to use this new xy. So y equals mx plus b. We multiply 1/3 times 6, that is 2. And then we add or subtract. This is a positive 2, so I'm going to subtract. So b equals 7. So again, our parallel line has the same speed, that 1/3, but it's in a different lane. Instead of it being in that negative 1 lane, it's going to be in the 7 lane. So it's going to start at 7. And then you can try the practice that goes with this. They all follow the exact same pattern. Okay, for the next one, the last section on this lesson, this is linear scatter plots and line of best fit. A scatter plot is just real life data. Real life data is not going to go up 3 over 1, up 3 over 1. It's not going to have perfect slopes all the time. Sometimes they do, most of the times they don't. Most of the time their slopes look like this. They're just kind of all over the place. The slope between these 2 lines would be different between the slope of those 2 points, or these 2 points, or these 2 points. They're all going to be different. So how do we find equations for this? Well, the first thing you want to know is your graph going up or down? So as the temperature, we're looking at temperature and ice cream cells. So as the temperature goes up, what's happening to the ice cream cells? So if the temperature increases, the cells, they're going up too, so they're increasing as well. So because all these points are just scattered everywhere, they don't really make a great line, we just find 2 points and we're going to use those to get an approximate equation. Your equation is not going to be perfect, but we're going to get it as close to perfect as possible. So we want to find 2 points that are on the line or super close to the line. And we don't have to worry about decimals or anything. We're just going to round these to the nearest whole number. So I'm going to go with, I like this one. This one's super close to the line. So that is 12, and I'll call that 195-ish. So 12, 195. because it's almost $200. And then I'm gonna go with let's go with this one. That's closer to the line a little bit. So this one, I'm gonna call it, I think that's closer to 19. 19 and 400. Okay. So I'm going to use those 2 points because they're super close to the line. You could have chosen this one. I would call that 16 or 17 and then 310, 320-ish if you want to use that. Or even this one up here or the very top one. Those are all super close to the line. So you could use any of these. So then we just use our slope formula. y2 minus y1 over x2 minus x1. So I've got 400 minus 195 over 19 minus 12. I can plug that into my calculator. Clear that. So alpha y equals, enter, 400 minus 195 over 19 minus 12. So I've got 205 over 7. And then we just, rate of change means write this out in words. So if I have 205 over 7, that's y over x. Y is my sales, so that's my money. So $205 per 7. This is degrees Celsius, your temperature. So it's increasing $205, your sales, for every 7 degrees that the temperature increases. Unit rate, if you remember back on lesson 3.5, unit rate just means the bottom, the x, needs to be 1. If it's not 1, just divide this. So we've got 205 divided by 7. And I can approximate this. So I'll go 29.29 if you round this up. And I'm still looking at dollars per degree. So it's $29.29 per degree Celsius. So my money, my ice cream sales is increasing $29.29 for every degree that the temperature increases. So again, you're not looking for a perfect slope here. You're rarely going to actually get a perfect slope. You just want to get it as close as possible to that line. Okay, sometimes they're not going to draw the line for you. So you can use a ruler and draw a line of best fit that goes through that hits as close as possible to these points, to all of your points. So they're not going to hit every single point, but we want to get as close as possible to them. Because we still have these two over here. Most of them are going to be closer to these top ones, because those form a pretty perfect line. But we still have those bottom 2 lines that we have to get kind of close to. But we can't just make a line that goes through here. That's not a line. That's a weird looking curve. So I'm going to pick 2 lines that are 2 points that are super close to these. So I'm going to go with kind of like this one. That is approximately 135. And then like this one. Because remember, we want to use whole numbers. This one right here, that's 3.5. So that's not a whole number. So I don't want to use that. So I'm going to go with a whole number, which is 3. And that one hits at 20. So 320. Okay, so we need a slope to make an equation. So I'm going to do y2 minus y1, x2 minus x1. I'll plug that in. over 3 minus 1. So I got negative 15 over 2. And then we need a y-intercept. So just like before, we want to plug into y equals mx plus b. So pick a point. I'm going to go with 320. So y is 3. My m, that was the negative 15 over 2 I got. X from my point is 3 plus b. So we multiply negative 15 over 2 times 3. It's negative 45 over 2. And then we're going to add this one because it's already negative to cancel it out. So 20 plus 45 over 2, that is 85 over 2. Now to see if we're close with the y-intercept, our line hit at approximately 42, 43. So I can check that in my calculator. 85 divided by 2, that is 42 and a half. So that is right between 42 and 43. So super close there. So this one's really good, 42 and a half. So we've got our slope, we've got our y-intercept. So we got y equals, and again, this is just a line of best fit. This is not perfect slope or y-intercept. It's just the best we can find. So negative 15 over 2 x plus 85 over 2. Nice. Yeah, that's the last one. Yeah, that's the last one. So go try to practice with these. If you have any questions, make sure you message your teacher.